Hello, everybody, and welcome back to yet another answer key video. So today we are going to look at the practice I had you do with regard to work and power. So without further ado, we'll make this one a quick one since there are only 4 exercises to do on this. So question number 1 starts, first off, how you doing? You guys doing all right? Excellent, glad to hear. I'm doing fine too, thank you for asking. All right, guys, here we go. Number 1, on his way off to college, Russell drags his suitcase 15 meters from the door of his house to the car at a constant speed with a horizontal force, pulling this way, of 95 newtons. A, how much work does Russell do to overcome the force of friction? B, if the floor has just been waxed, does he have to do more work or less work to move the suitcase? And explain. All right, so let's start up with this. We're going to get on here and see what we can do here. So work, as we know from our equations, let's do a quick review. Our equation for gravitational potential energy, mgh, mass times gravity times height. Our equation for kinetic energy, 1/2 mv squared. That is the mass times the velocity squared. Whoa, I don't know what's going on with our focusing here, guys. Bugging out a little bit. Back to, I think we found the golden distance. All right, work is force times displacement, and power is work divided by time. So let's start off by trying to solve this one. We have some information. We see that he's dragging suitcase 15 meters. So we have a displacement of 15 meters, and we know that he's using a force of 95 newtons. Okay, how much work does he have to do? Well, work equation is force times displacement. So all we have to do is take our force, 95, multiply it by our displacement, 15. And in doing so, we get 1425. I will just make sure here, 95 times 15. 1425. And what are the units for work? Perfect, joules. All right, excellent job. So that was for A. Now for B, if the floor was waxed, does he have to do more or less work? The floor was waxed, does he have to do more or less work? And you said, come on guys, speak up, I can't hear you. You said less work, very good. Less work because we are decreasing the frictional force. Because decreasing F of F. Remember that, right? F of F, force of friction. All right, guys, perfect. Let's move on to number 2. All right, number 2. Katie, a 30-kilogram child, mass 30 kg, climbs a tree to rescue her cat who is afraid to jump the 8 meters to the ground. So we have a displacement or a height. We're really not sure yet. 8 meters, I'll put a little question mark there. 8 meters to the ground. How much work does Katie do in order to reach the cat? All right, so now she's got to climb up. So here is your tree, there's the limb, here's the little kitty cat right there, and there's his tail, right? It doesn't look like a cat, I know, but see, you guys are so far away that you really, it's actually a great drawing of a cat. You buying that? Believe that? No, neither do I. All right, anyway, so she's got to climb up this distance. What is the work she has to do? Now, here is where we need to think a little bit and actually define what is work. Well, when you lift something up, right? If I lift this calculator up, I am doing work. But I'm also giving it what? I'm also giving it GPE. Remember, we talked about this. We said that potential energy, and in this case, gravitational, can be equal to work. So I'm going to show you the 2 ways to do this, to prove to you that GPE is really equal to work. So first, let's say work equals FD. It's the equation. So the D in this place is 8 meters. But what is the force? She's climbing up a tree. What is the force that she is overcoming, that she must exert to climb up that tree? What force does she have to exert, go against? Gravity, correct. And how do we solve for the force of gravity, guys? F of G equals mg. All right, so this force here is really, I'm gonna put a little g in there, right? That force with a g, this is gravity, so that's really mass times gravity. Does that look like an equation? mgh, but it's the work equation. So we've just proved that work, in this case, is really gravitational potential energy. And that right there is the answer. When we do this out, we get 2,000, let's see, just to make sure, 30 times 9.8 times 8, 2,352 joules. All right, guys? So remember, you have to keep in mind that work and force are essentially the same thing, just asking it a different way. And you can never, ever forget F of G equals mg. All right, just 2 more to go, and we are done for this video. It's a quick one. Number 3. Marissa does 3.2 joules of work to lower the window shade in her bedroom, a distance of 0.8 meters. So we have the work as being 3.2 joules. We have the distance as being 0.8 meters. How much force must she exert on the window shade? So we know our equation, work equals FD. 3.2, plug it in, F times 0.8. What do we need to do? Divide, very good. And we get a force that is equal to 3.2 divided by 0.8. Goodness. Oh, you guys should be able to do this in your head, mental math. I should have been able to do it in my head. 4 newtons. All right, excellent job, guys. We got 1 more to go, and that is it. All right, number 4. So we got 2 guys, Atlas and Hercules, 2 carnival sideshow strongmen. Each lift 200 kilogram of barbells 2 meters off the ground. Atlas lifts his barbell in 1 second, while Hercules lifts it in 3 seconds. Which strongman does more work? Calculate which man is more powerful. So let's look at the work aspect of it first. So we have got Atlas A and we've got Hercules H. We both know that they are both lifting a mass of 200 kilograms, and they are both lifting it a distance of 2 meters above the ground. So we need to figure out which man does more work. All right, here we go. So work is equal to FD. And we don't have a force, but from 2 questions ago, we reinforced that work is actually equal to energy. And in this case, gravitational potential, because we're taking a barbell and we're lifting it up, right? 2 meters, mgh. So we're gonna say work is equal to mgh here. GPE. So work is equal to 200 times 9.8 times 2. The work that Atlas did, let's see, 200 times 9.8 times 2, he did, oopsies, 3,920 joules of work. That's the work that Atlas did. Now Hercules, he took the same 200 kilograms. He lifted it the same 2 meters. He opposed the same force of gravity. How is his work going to compare? Perfect job. It's the same. So in fact, both guys did the same amount of work. They lifted the same mass and the same height. They did the same. Okay. Same W, same work. All right, last thing we had to do was figure out their power. So for that, we were given some times, and it said Atlas lifted in 1 second, so time, and Hercules did it in 3 seconds. How do we find power? Power equals work divided by time. P equals W over T. 3920 divided by 1 comes out to 3920. What are the units for power? Watts. Very good. That's Atlas's. And Hercules, power equals work over time. So 3920 joules was his work, same work, but now his time is different, divided by 3. 3920 is 1307. I rounded watts. So which man is more powerful? You see that Atlas, because he did the same work in a shorter amount of time, he is more powerful. All right, guys, that is it for work and power. I hope this has helped you out. And you can expect another set of practice problems on the way. And I will make another answer video for that one. And then we'll be having a quiz pretty soon. So smile, make sure you get all this. And I will see you guys on the next video. Take care, everybody. Bye-bye.